Hello and welcome to our practice packet again. Angle side angle and angle side. So the angle side angle postulate shows that two triangles are congruent by the angle side angle pattern, and you should have watched the video on it, as well as the angle side theorem, which is kind of by default an angle side angle theorem because you should know, well, I won't get into it, but this is the one you should be cautious about. Just because it looks like angle side in two triangles doesn't mean they match up appropriately. So just keep an eye out on that and watch that video again if you are wondering what I'm talking about. But now we could prove triangles are congruent by angle side angle and angle side, both of which have two angles in them. So we need to be very cautious about where that side is in fact located. Is the side sandwiched between the two angles, or is it outside of it? And if it is outside of it, does it follow the same tick mark pattern? So even more we need to be cautious about. So let's just keep our eyes peeled. So in this first set of problems, I'm not going to go through this. We already know them. Informal proofs. So can you prove the triangles are congruent by all four of these postulates, if at all? Or not congruent, or not enough information? So we have a lot of things to just consider. How many sides are given, how many angles are given, and if it even follows one of the patterns, or is it one of the not congruent or not enough information pieces. Looking at A. Well, how many angles are given? 2. Per triangle? Absolutely. How many sides are given? 1. So it follows the angle, 2 angles, 1 side. Has to be one of these two, right? Now, the question then becomes, is the side sandwiched between the two angles? It absolutely is in both cases, so this has to be angle side angle. That's how you know. That's the first thing you should fill out. Then you complete the triangle statement, the congruency triangle statement, and we are starting with ABC, from A to B to C. So I've been kind of doing this. I haven't been using highlighters for it, but I do this kind of pattern. I go from the no tick angle, so there's nothing here at A, to the 2 tick to the 1 tick. Okay, we need to follow the same pattern in the other triangle. No tick to 2 tick to 1 tick. And that's how we know how to name the triangle properly. If we don't name this triangle properly, then we are going to get this part of the statement wrong, and that is not good. So following the pattern, it goes from D to E to C. Triangle D to E to C. Notice that this has triangle here already. If it wasn't there, we definitely need to drop that in. Moving on to the second one. We have 2 angles and we have a side. Okay. Do we have 2 angles and a side in the other one? Absolutely. Does it follow? And the question then becomes, where is the side? The side, is it sandwiched between the 2 angles? It is not. It is outside of it. So the next thing we should check is this side next to the same angle tick in both triangles? If it is, awesome. That is for sure angle side. If it is not, then it is not congruent or not enough information, depending on the type of triangle it is. More often than not, it would be not congruent. So in this case, the 1 tick is next to the 1 tick angle. The 1 side tick is also next to the 1 side tick angle, or the 1 angle tick. So this is angle side. And then let's do our highlighter. We're going from S to T to R in the first statement. So we need to follow the same pattern. We're going from the 1 tick angle to the right angle to the none. The 1 tick to the right angle to the none. VWU. Triangle VWU. Number 3, or letter C, I should say. Well, we have parallel lines here. And anytime we have parallel lines, we could use the angle pair relationships. You could always draw your parallel lines and the transversal. Or if you know this pattern, when you have parallel lines, you could always, in a transversal, you could always do a Z. And anytime you do a Z, alternate interior angles are drawn. But if you do it the old school way, connect red to blue, and you have alternate interior angles here. There's an angle pair relationship that we consider. This one's alternate interior angle. So these are in fact congruent. We also have two sets of tick markers in each triangle, okay? So now we definitely have some two sides and one angle, so it has to be side, angle, side. Last question we should ask, is the angle sandwiched between the two sides? It is in both cases, okay? So we could definitely say side, angle, side, and then we could read the pattern. PRS, so P to R, P to R to S. So that means we're looking at the left triangle first. We're going through the 3 ticks, and then through for the sides, we're going through the 3 side tick and then the 2 side tick. So if you follow the same pattern, it goes R to P to Q. Okay, and it would actually be a lot easier if I did this. P to R to S, and then we follow the same pattern from 3 ticks through the 2 ticks, through the 3 ticks, through the 2 ticks. So we go R, P, Q. Triangle, R, P, Q. Okay, let's go to the next one. D. This one hopefully is obvious. 2 sides, 1 angle in both pieces. The angle is sandwiched between the 2 sides, so it is side, angle, side. And then let's follow the pattern. Let's highlight. Okay, first one. D to F to E, through the 1 tick, through the 2 ticks. Okay, so the same pattern, through the 1 tick, through the 2 ticks. And we're going J, triangle J, H, G. E. Well, there's only 2 pieces of information marked in both triangles. So we either need to find another piece of information, otherwise it is not enough information. And hopefully, since this is a bow tie problem, because it looks like a bow tie, we have vertical angles. We have an intersection there. Anytime we have an intersection, we have vertical angles, and we have these 2 sets of congruencies. Now we have 2 sets of angles, 1 side. So it has to be either angle, angle, side, or angle, side, angle. So where is the side? Is it sandwiched between the 2 angles, or is it outside of it? In this particular case, it is outside of it because it is not between the 2 angles in both cases. So the last thing we should check is the side attached to the 1 angle tick. In this case, it is. So it does follow the angle, angle, side pattern. The reason why I say that is because what if the angle is here instead of here, or the side, I should say? Well, in this, if I change this diagram to have the 1 tick marker here, then it is still angle, angle, side, right? Because it's outside of the sandwich, but it is attached to the 2 ticker. In this case, it's attached to the 1 ticker, and it's not the proper order. So just keep that in mind. This is definitely angle, angle, side because it is attached to the appropriate pieces of information. Okay, and let's do some highlighting. E, F, G. So it's starting at the 1 angle tick, going through the 1 side tick, and then going to the 2. So it follows this pattern. G, H, J. Triangle J. I'm sorry, J, H, G. I said that backwards. And we're done. Last but not least, we have 2 sides, 1 angle. So in 2 sides, 1 angle. So it has to be, by process of elimination, it has to be side, angle, side, right? Well, is the angle sandwiched between the 2 sides? It is not here. It is in the second one, but it is not in the first one. So we don't definitively know if it is side, if these are congruent. There is the possibility that it is congruent in this particular case, but it is not. So this is, in my opinion, not enough information. Okay, and we'll leave it at that. So those are your informal proofs. We have 4 ways to do it now. Keep in mind, be extra mindful for angle, angle, side. Looking at some what additional information problems. What additional information do you need to prove that the triangles are congruent using the following theorems or postulate? Well, if we're looking at A, if we want to solve by angle, side, angle, there's only 1 piece of information here, but there's a connected side. So we do have the reflexive property. So that means we have one angle, one side. That side has to be sandwiched between the two angles, and the only possibility for it would to be these two. I'm going to put 2 ticks and 2 ticks. So we definitely need to say angle QCD has to be congruent to angle ECD to prove angle side angle. Okay, same thing for B. If we needed to prove angle side angle, well, we definitely see an intersection, which means we'd have vertical angles. 1 tick, 1 tick. And now, since we're doing angle side angle, the side has to be sandwiched between the two angles. So I'm going to drop in 2 tick markers that is sandwiched between these two angles in both cases. Okay, so we need to say CS has to be congruent to RS. Moving on. C. If we're proving by angle side, well, we definitely need, there are 2 answers to this. And I'll show you. Because if I mark, right now it's angle side, right? And we have 2 angles that are marked. Now, if I marked this one, that's not angle side, that's angle side angle. But if I mark this one, that is angle side going this way. But if I mark this triangle, or this side, it is angle side going this way. I use 2 different colors for 2 different reasons. So there are 2 possible answers for this to show angle side. I'm going to mark this one first. And if I follow the pattern, it could go 2 ticks to 3 ticks to none. So 2 ticks to 3 ticks to none would show NM. So this could be YZ is congruent to NM. And this is going to be a big OR. We could also have these ticks. Sorry, let me do that in blue again. And then we went from, if we could do it this way, angle, side. That means we're going 3 to 2 to none. 3 to 2 to none. So that means we could show NL is congruent to, I'm sorry, let me start with the left side. ZX is congruent to NL. So there are 2 possible ways to show angle side if you need to drop in additional pieces of information. All right, so 2 column proofs. First one's a skeleton, which is really nice. Write a 2 column proof. And the first one is already given. The first statement's already given. Okay. We use that piece of information to prove something else. In this particular case, I'm actually going to say, well, we have these 2. We could draw this Z in if we wanted to just show, hey, we have alternate interior angles here. Okay. Always mark your diagram as you're doing it. I'm going to call that angle 1 and angle 2. Angle 1 is in fact congruent to angle 2. If parallel lines, then alternate interior angles are congruent. I'm gonna put an A here because those are angles that are congruent. I'm going to draw a line here to kind of end my paragraph because we have a congruency statement. And I'm going to go to the next given because it is provided for us that should be the next line. CBA, angle CBA is in fact congruent to angle ADB. So CBA is right here. I'm going to put this 2 ticks. ADB, and that should actually say ADC. That's a typo. CBA. ADC. Yep, that should be this one. So there's a typo there. Let's fix that really quick. ABC, CDM. This statement is correct, which is good. All right. Because that wouldn't make any sense for it to say ADB. ADB would mean that, and that doesn't make any sense. So we also have these 2 angles that are congruent. Since these are congruent, that is an angle that's congruent. And the paragraph. And then line 4. Well, there's no more givens to use because we use both of them. First one being the parallel lines leading to angles, alternate interior angles. Second one is a congruency in itself. But we should also recognize that we have a shared side here, AC, which is congruent to itself. So we could say AC is in fact congruent to CA, if you want to be cute about it. And this is the reflexive property. And last but not least, we have the proof statement. ABC, I'm going to go from A to B to C. So we're going through the parallel line from one tick to two angles, one tick to two tick to none. And then we're going to go C, D, A. And it does follow that pattern. So what's the reason? Well, we have two angles, one side, and it follows the pattern angle, angle, side. Okay? The side is outside of the sandwich in both cases. Angle, angle, side. Step 2, if you want to try this one on your own, pause the video, give it a shot. And here we go. Write a 2-column proof, given S is congruent to V, that is already given. So we're going to put an A here. We're going to draw a line to end the paragraph. We have that congruency. Ooh, this is one thing I forgot to do in the last video. This is actually sides that are congruent. If you want to, you could start putting this by numbers 2, 3, and 4. It's just telling me which statements actually have the congruencies. This should already do that in itself, but it's just a good way to stay organized with your congruency statements that are actually proving the angle, angle, side. Okay? So, back to number 2. S is congruent to V. Mark that in your diagram. And then we have T is the midpoint of SV. That's going to lead to a new piece of information. T is the midpoint of SV. Shows that ST is congruent to TV. I'm sorry. T is the midpoint. This is also given. Number 3, if a point is the midpoint of a segment, then it divides the segment into two congruent, that's terribly written, two congruent segments. Okay, that is a side congruency that will end the paragraph. And then we go to number 4. Well, we already used both givens. Those are done. So what can we do? Well, we can look at the diagram. The diagram has two intersecting lines. This is a bow tie problem. Bow tie problems usually have vertical angles. Okay, and we could say, instead of going RTS, I'm going to say that 1 and 2, angle 1 is in fact congruent to angle 2 by the vertical angles. If two angles are vertical angles, then they are congruent. And there is my last angle. If you read this, it says angle side angle. Be careful. Still look at your diagram, because your diagram is what's going to show you how it's oriented. The side is sandwiched between the two angles, so this is actually true. Angle side angle works. Okay? It's not always going to be, if that's at angle, if we reordered this, it could write angle, angle side, and that is not always correct. So read your diagram for that statement. RTS and UTV by angle, side, angle. All right. We have 2 more. Write a 2-column proof. If you want to try this one out on your own, this one's 6 steps. It is mostly blank. If you want to give it a shot, go for it. Pause the video. Okay, here we go. First one. I'm actually there are 3 given statements, which is wild. First one I'm going to do is CD bisects AE. Okay? CD bisecting AE just means that this segment is cutting this one into 2 equal parts. segments could bisect each other, bisect another segment. Doesn't quite matter, but if a segment bisects another segment, specifically AE, then AE is being split into two congruent parts. And those two congruent parts are AC and CE, which we could state. AC is now in fact congruent to CE. And you write your if then. If a segment bisects an angle, or bisects another segment, in this case, bisects another segment, then, that should be a comma, then it divides the segment into two congruent segments. Okay. Next line. AB is parallel to CD. So actually this is a congruency statement. That's showing sides are congruent. So I'm going to draw a line ending the paragraph showing, hey, we have one congruency. We need two more. Next line. AB is parallel to CD, given. But this leads to a new piece of information. Since we have two sets of parallel lines here, and we have a transversal, well, what line is actually going through both triangle or both blue lines? Well, we actually have two of them here. This one, this purple one, but I wouldn't use that one. I would actually use this one, because this one will show. Let me move this properly on the line. If we turn our page and look at it sideways, it will show that these two angles are corresponding angles, right? They're in the same position. Top right of the intersection, top right of the intersection, okay? And it might be helpful to look at it completely separate from all of this. So we could see it here, top right, okay? Which means they're corresponding angles. I'm going to call that angle 1 and angle 2 because I don't want to name them the full angle name. It's a lot easier to just say angle 1 and angle 2. And the reason would be if parallel lines, then corresponding angles are congruent. That is another angle congruency, or I should say a angle congruency. I'm going to have to do that a little bit on an angle. And last but not least, angle E is in fact congruent to angle BCA. Now, this is another angle congruency. Angle E is congruent to BCA. And now we have a full slew. We have three pieces of information. This is actually a given. So now we have the proof statement because we have three congruencies. We can't do this until we have three congruencies. So this is the moment we know we could finish the triangle congruency statement. The triangle congruency statement is filled in already. All we have to do is figure out which property or postulate or theorem we're using. Looking at our diagram, we see the side is sandwiched between two angles, which leads us to angle, side, angle. And we're done. Okay. Last but not least, completely blank proof. You're going to be expected to do these for your quiz. If you want to pause the video, give this one a shot, go for it. And here we go. Well, first statement. Angle S is congruent to angle U. First reason, given. Okay, it's already marked on your diagram. I'm going to put an A here to show the congruency. And I'm going to go to line 2. Line 2 would be TR bisects angle STU. Given. Now, anytime a segment bisects an angle, it divides the angle into two congruent angles. So I'm going to have a third statement here. I'm going to put angle 1 and angle 2 here, because STU is the one that's been bisected, and it's already marked for us, which is a huge clue. Angle 1 is congruent to angle 2. And we're going to use a combination of these two statements. If a segment bisects an angle, then it divides the angle into two congruent angles. This is showing these two are congruent, so these are angles that are congruent. I'm going to end my paragraph. I'm going to put a statement 4. Okay. Now we already used both givens, so there's nothing left to actually use except for the diagram. Diagram should have a reflexive property because they share that side RT. RT is a congruent to itself. If you want to be cute, TR. Reason is the reflexive property. And now it's showing sides are congruent. Now looking at our diagram, we have two angles, one side, and is the side sandwiched between the two angles? No, it's not. Is it positioned in the same position in both triangles? Well, it's attached to the 2-tick marker. Attached to the 2-tick marker, so it is. So we are good to go. Line 5. We know it is for sure going to be the proof statement. It's always the last statement. SRT is congruent to triangle URT by angle, side, as we already discussed. Oh, I've been forgetting to do this. By numbers 1, 3, and 4, because this is the actual congruency statements. If you want to go back and do it for this would be numbers 2, 4, and 5. It doesn't have to go in the order of angle, side, angle, but if you want to, just for completion's sake, angle, side, angle would be 4 to 5 or 5 to 4. This one would be numbers 1, 3, and 4, and then we did it for number 1 already. So here's a 5-stepper, and there's your 2-column proofs. That's completely blank. Hopefully you tried that one on your own, but if you didn't and you want some extra practice, you could always retry these, okay? If you do have any questions, please let me know. I will see you in the next one. Bye.